Hello friends, today we are going to start a second chapter. Actually in syllabus this is the first one, but already we have covered the second chapter from syllabus, which was the other semiconductor devices. So we are moving towards the next chapter, that is a Thyristor. Okay. Okay. So first of all, let me introduce you about the Thyristor, how the word Thyristor is invented. Previously, before invention of a thyristor, that is in I guess 1958 or 1963. Before that, people used to use a thyratron tube. A thyratron tube is a particular tube which was utilized to work as a thyristor. Okay, and then later even transistor was invented. So the thyristor is a device which is having a characteristics which are similar to the thyratron, but at the same time its construction, there is a PNPN. Okay, so we can say it is a PNP or NPN. So its construction is somewhat similar to a transistor. Hence, by taking capital letters THYR from thyratron and ISTR from transistor, the word is invented as a thyristor. One interesting thing is actually previously that this thyristor was called as a silicon control rectifier. Okay, till I guess in some 1963, I guess in some 1963, International Electrotechnical Commission in 1963 they decided that this device can be called as a thyristor. Previously, it was known as a silicon control rectifier or SCR. Okay, so this is a four-layered three-terminal device. Already we have covered diode, BJT, IGBT, MOSFET. So you know you are familiar with this terminology. Okay, so this is a four-layered and three-terminal device. It has a highest power handling capability. Its rating are from 10 kilovolt, 3000 ampere in power rating 30 megawatt. These are some huge ratings of this particular device. And the one good thing is, though it has a huge rating, it can be turned on by using only 1 ampere and 10 watt supply. Okay, so that is a important point. It has a switching frequency from 1 kilohertz to around 20 kilohertz, and it has a four modes of conduction or blocking, whatever. It has a four states, I can say. It has a four states. First is a reverse blocking mode, then reverse conduction mode, then forward blocking mode, and forward conduction mode. Actually, in some books they have given only three states, that is a reverse blocking mode, forward blocking mode, and forward conduction mode, because reverse conduction is not recommended. Okay. Symbol and construction. So here we can see this is a symbol of a SCR. It has three terminals: anode, cathode, and gate. Okay, and its symbol is like a diode only, but it has a one gate terminal. Okay, it is a gate terminal. Now, one important point is SCR is a control device, because as you can see its symbol is like a diode. So let me tell you that it is a control device. Means what exactly it means is, see, diode get turned on when it gets supplied. This is not the case with the SCR. SCR get turned on when you apply a gate pulse, then only it get turned. Second thing, diode blocks reverse voltage. Similarly, SCR also block reverse voltage. Okay, and diode is uncontrolled device. You can't control its output. SCR, yes, it is a control device. You can control its output. So this is a four-layer device. You can see P N P N. As there are four layers, there are three junctions: J1, J2, and J3. Okay, three terminals: anode, cathode, and gate. Okay, so this is a cross section. Cross section. Anode is connected to the P, then cathode is connected to the N, and gate is given to the nearest P of a cathode. Okay, so here you can see where gate is given to the P. This is the cross sectional view. Now if I bisect this SCR, means just to see compare the characteristics, then we can bisect it like a PNP and NPN. See here, split sections PNP and NPN. So this is how it works as a two different transistors. Okay, hence two transistor analogy come in the picture. What is that? We'll see later. Okay, just now we'll see only construction. So this is how we can split it. Now these are some structural details. What are structural details? Okay, what the doping level and everything, width, everything is given in this particular diagram. So don't get confused. Anode is connected to P, cathode is connected to the N. Here there are two separate N. Don't worry, these are short circuited. Okay, and in between P and PN. Here another P layer is there. Don't get confused. This is a single layer. Okay, P, then this is N, then this is a P, then this to N. So four layer device. Okay, then what is difference? This is a P plus, this is only P. P plus means highly doped. Highly doped means 10 raised to 19 per cm cube. Okay, this is normal material P, 10 raised to 70. This is lightly doped. This is lightly doped. Okay, so it is a 10 raised to 13 to 5 into 10 raised to 14 per cm cube. Okay, this is again lightly doped, 10 raised to 17, and this is n layer, which is again highly doped, 10 raised to 19. What about the width? This P layer has 30 to 50 micrometer width. Then this have 50 to 1000. This has a width of 30 to 100, and this has a width of 100 micrometer. Okay, so this is the constructional details of a SCR. Now we will see static IV characteristics of a SCR. Here we can see this is a its representation PN. Now here we have seen there is a SCR, and to turn on this is a circuit diagram of a thyristor to make it on. Now as I said, three important modes are reverse blocking mode, forward blocking mode, forward conduction mode. What is reverse blocking mode? See, this is the IV characteristic or switching characteristics. This is I, this is V. First quadrant, second quadrant, third quadrant, fourth quadrant. In fourth quadrant, when generally what we have to do, anode should be positive, cathode should be negative, and gate pulse should be given, then it will conduct. But if anode is negative and cathode is positive, then what will happen? See here in this diagram you can see when K is positive with respect to A, then this NP will be reverse bias. This NP will be reverse bias. Only junction, this PN, is forward bias. Okay, so thyristor will not conduct. So you can see here, see, though you goes on increasing voltage, in a reverse way, it will not conduct. It will not conduct. There will be a small current. There will be very small current, which is called as a reverse leakage current. And the mode is called as a reverse blocking mode. Now, if we further goes on increasing voltage, then a limit will come, which is called as a breaking voltage, VBR. A limit will come at that point. Avalanche breakdown will take, and the junction J3 and J1 will get breakdown, and it will start conducting. But it is very risky. Device may get damaged. Okay, so it is, and this when it start conducting, that is called as the reverse conduction mode. But as I said, that is not recommended. Hence, we can see it is not included in that particular mode. Okay. Okay. I'm sorry. Yes. So hence this is a reverse blocking mode because it is not conducting. Here it start conducting, there is a reverse conduction, but it is not recommended. Next mode is a forward blocking mode. Forward blocking mode means now if I made anode positive and cathode negative. Okay, but gate is open, gate is not given. Only anode is positive, cathode is negative. Then what will happen? As you goes on increasing voltage, some leakage current will flow. Okay, now junction J1 is a forward bias, PN, right? No, PN is a forward junction. Here junction J3, that is P to N, it is also forward bias. Only junction J2 is not forward bias, it is reverse bias. Okay, so it will not conduct, but there is some leakage current. So here you can see this is a leakage current. Voltage is increasing, there is some leakage current, and till this point, breakover voltage, it will block. Device will not be conducting. Now at this particular voltage, that point M, your junction J2 will get breakdown, and from when it get breakdown, suddenly the impedance will decreases. So suddenly you can see means the voltage which is blocked, which is not required right now. So suddenly voltage will come to very less value, and then current will rise because now the impedance is not present. Okay, so it will start conducting. So this is a forward blocking mode, and third is a forward conduction mode. Okay, forward blocking means till from here till point M, this is a forward blocking. Forward conduction means what? When anode is positive, cathode is negative, and some gate pulse is given at this point. Now, when gate pulse is given, what will happen? This PN is a forward bias, this PN is forward bias, and gate pulse is given. then this gate